Good morning, students. Today I am explaining you the Kirchoff's laws. The first Kirchoff's law is the Kirchoff's current law. Gustav Kirchoff's current law is one of the fundamental laws used for circuit analysis. His current law states that for a parallel path, the total current entering a circuit's junction is exactly equal to the total current leaving the same junction. This is because it has no other place to go as no charge is lost. As I already told you when explaining the network terminologies, so junction is nothing but where more than three active or passive elements will meet. We call it as a junction. Okay, so according to Gustav Kirchoff's current law, the current entering a circuit's junction is exactly equal to the total current leaving the same junction. Okay, so in other words, the algebraic sum of all the currents entering and leaving a junction must be equal to 0. That is summation of I in is equal to summation of I out. So I have shown you with the help of diagram the algebraic sum of all currents entering. So that is plus here and leaving any point, that is junction, in a circuit must equal to 0. So we can see in the diagram the current I1, I2, I3 are entering to the junction, right? Then the current I4 and I5 are coming out of the junction. Here the three currents entering the node, that is I1, I2 and I3, are all positive in value, and the two currents leaving the node I4 and I5 are negative in value. Then this means we can also rewritten the equation as I1 plus I2 plus I3. Okay, so we have written plus because they are entering to the junction. I1, I2 and I3 are entering to the junction. That's why it is denoted as a with plus sign. Then minus I4 minus I5 equal to 0. I4 and I5 leaving the junction. So they are shown as a with the negative sign. That totally equal to 0. Okay. So then Kirchoff's voltage law. Gustav Kirchoff's voltage law is the second of his fundamental laws we can use for circuit analysis. His voltage law states that for a closed loop series path, the algebraic sum of all the voltages around any closed loop in a circuit is equal to 0. This is because a circuit loop is a closed conducting path, so no energy is lost. Okay, so what Kirchhoff's voltage law will say that the algebraic sum of all the voltages around any closed loop in a circuit is equal to 0. In other words, the algebraic sum of all the potential differences. So potential difference and voltage both are same. So you also call it as electromotive force around the loop must be equal to 0 as summation V is equal to 0. Note here that the term algebraic sum means to take into account the polarities and signs of the sources and voltage drops around the loop. So you can see in the diagram. So below is a single loop circuit. The KVL computation is expressed graphically in that voltages around a loop are summed up by traversing the loop. For example, so in the circuit we can see I have 10 voltage source and R1, R2 and R3 as resistors, and voltage drop across R1 is VR1, then voltage drop across VR2, R2 is VR2, then voltage drop across R3, resistor is VR3, then resulting KVL law is equal to VR1 plus VR2 plus VR3 minus 10 equal to 0. Here minus 10 is written because the current is flowing in the anti-clockwise direction. So that's why the voltage is written as minus 10. Okay. So this is the KVL law application circuit. So KVL law can be applied in the circuit like this. So these are about the Kirchhoff's voltage law. Okay. So today we studied about both the Kirchhoff's current law and Kirchhoff's voltage law. So further we will discuss in the next classes.